to a conservation area, there's limits to some of the things that we can do. All these things should be taken into consideration when you're looking at building and renovating. So I'm going to quickly flip through here. I love putting this up here. Einstein's description of insanity, doing the same thing over and over and expecting different results. Point being, if we build to the same standard, we're never going to move forward. We have to engage the builder, renovator, and we have to be the driving force saying, this is what I want. I don't want that minimum building code. I want something more. When you're organizing your build or your reno, obviously we have code requirements. What code or regulations apply, who's responsible. We've got our goals and objectives. What level do we want to build to? Are we going lead H? Our limiting factors, environmental considerations. We have to find a workforce that is appropriate to what we're doing. If we're doing solar thermal or there's a lot of companies out there now. Rick's a great example of a good company that can provide the proper design services that you need or install services that you need amongst a lot of others that we have. We've got Down Under Solar, and I could go on and on as to the qualified contractors out there, but there are an equal amount of unqualified contractors. Get references and establish your timeline as with any build. Your design criteria, obviously your grants and programs are going to play a large role in that. You have architectural and structural systems. How are they affected by the other systems you're putting in? Do we have a large load of solar thermal on the roof? Do we have wind vibrating on a tower that's close to it? Mechanical's a big one. What's our budget comfort level? And how is that integrated with our other systems? We're talking about green stuff here. We're talking about green energies, again, our solar thermal. Is that going to provide some of our heat for the in-floor system, or is it just going to do our domestic water heating? And our electrical, obviously, if we're going to do a PV system or an entirely off-grid system, what are the requirements of it? These are the things that we need to figure out before we engage into these endeavors. I'm going to flip through a couple more here because I don't want to take up too much of your time. Orientation of the home. Now this is a great slide. The orientation of the home when we're planning to build plays a huge part of it. If we turn that house a certain way, we reduce the cooling load. We might reduce the heating load because we're going to get some passive solar gains. I love pushing overhangs. They're a simple thing that's in part of your home already, and if it's looked at appropriately, can make a big difference. We can block summer sun coming in to reduce our gains while still allowing winter sunlight in. This is something that's part of your house already. Let's just do it right. And to that, our passive solar, what kind of thermal mass are we allowing that solar to collect in? All these things are simple things that can be done. So those are just a couple of points that I just went over. Our structural components, solar optimization. What's our roof size? What's the roof pitch? If we're looking at putting a complete solar system in, we can design that roof pitch. We've all seen all kinds of houses with crazy roof pitches and hips and gables and lots of other fun stuff. Why not have that solar-ready roof? It's a simple thing. Again, it's part of your home that's already there. Let's look to the future on it. Talked about the structural loading, the additional weight applied by some of the systems, and those kind of considerations. Energy storage, if we're looking at a completely off-grid system. And when I say energy storage, I'm not just talking about batteries. Solar thermal storage, if we're using for an in-floor system, which is a very difficult thing to do. It requires a huge amount of storage because when we want heat, there's not the sun providing the heat. Our heating systems, depending on where we live, will use 60, 70, 80% possibly of our energy uses in water heating and space heating. So when we're looking at our mechanical systems, even if we're just going with a straight forced air gas system, it should be the most efficient. It continues to consume year after year after year. If we look at a 50-year carbon footprint of a home, 70% of it is in fuel consumption. And it needs to be designed to use the energy efficiently. So if we have a piece of equipment that's in a home that's too large and we get short cycling, we're not using that piece of equipment efficiently. It's not coming up to temperature and allowing that heat to dissipate properly. And it needs to be integrated with the other systems. If we're doing a boiler system that's firing an in-floor as well as our forced air side, those things all have to work together properly. Are we zoning it? There's any number of different considerations on that. Cooling systems is normally the largest electrical draw, primarily because we have compressors. They use a lot of electricity. Even geothermal systems, and we're going to have other people talk about them, so I won't get too in-depth with them. A lot of geothermal heat pump systems still have compressors in them. If we're looking at electrical loads, those are some of the things that we really need to consider. Anything that can reduce the loads of a cooling system, like orientation, like overhangs, should be considered. Again, we have huge consumptions in cooling systems. And the problem with cooling systems is we have peak demand problems right now. And our utility companies can talk about this. In the middle of the summer, we used to have commercial peak demand issues. So when all the factories are coming online, that's when we use the most energy. Now, it's 3 o'clock in the afternoon when everybody's turning on their air conditioners. Those peak loads are what's putting the strains on our systems. So if we can reduce the cooling loads, then that's going to help everybody all around. There's also natural elements that can accomplish part of that as well. Shading from trees. We have a great way of taking fields, leveling them, and putting up great big houses with palladium windows faced whatever way we want, so that the neighbors think we have a really nice house. We need to stop doing things like that. Ventilation. This is where the health part comes in. Our ventilation is separate from exhaust, humidification, dehumidification, and filtration. This is something that when HRVs were brought out, heat recovery ventilators, it has been commonly confused with an exhaust system. So we're pulling air from the bathrooms, we're exhausting that outside, we're bringing fresh air in, we're crossing it with the airstream to retain some of the heat, and putting that fresh air, warmed fresh air, back into the house. Typically, especially in this area, we've combined those systems. The expectation from a homeowner standpoint, and my expectations as a homeowner, is that when I have a shower, I want that moist air gone as quickly as possible. An HRV doesn't do that. It's designed to provide ventilation at a slow, steady rate. An exhaust system is an exhaust system. If we want 10 minutes of exhaust from a bathroom, then we should get a bath fan to do that. Humidification and dehumidification, an HRV that is typically used for ventilation will only dehumidify in the wintertime when we don't need dehumidification. So we need to design to the specific task we're looking for. Filtration, we have lots of HEPA filtration. We have electronic air cleaners to look for. Again, a lot of this is going to be based on your particular health issues. One of the big requirements, or one of the big points, is negative and positive pressure systems. We can design a ventilation system that is based on a negative pressure, but that enters a whole other path of problems, not only in the health. We can change chimneys, make them go backwards, introduce CO2, but the durability of the building is now affected. If we start forcing warm, moist air through a wall, we can rot the wall structure. One of the big debates right now in the building science industry is whether we should even have vapor barriers at all in our homes. And primarily because of air conditioning. If we look at our basements, everybody's got a basement that's like a meat locker in the summertime, because all that cool air that's trying to satisfy that thermostat that's upstairs is typically in the basement. That basement now is cooled, and our condensing surface is our vapor barrier and is on the inside. There's many houses out there that have water along the bottom plate in the summertime for that very reason. We're allowing that to condense. I would be surprised in the next code update that the requirement